Hi everyone. This lecture series we discuss about the autonomous connected vehicle. Generally, the lecture series they explain only the theory, then they explain about some practical components. Especially this lecture series, we use the LabVIEW platform to learn the entire course. So in this autonomous connected vehicle, initially this video where I explain about all the basic introduction and what all other things we are to learn in this series. The next continuous series, we discuss about the how to use the LabVIEW platform. Actually, the LabVIEW platform is the student version is the student can able to install that LabVIEW software and learn the content through the LabVIEW platform. Now we go, what is kind of the series means? First, I will explain about the overall theory, then how to experimental setup, how to develop in the LabVIEW model, and they give some tasks to the student. Now, first, why learn the autonomous and connected vehicle? Everyone know about the nowadays the electrical vehicle is a very booming. Everywhere you go, the electrical vehicle is there. Everyone purchase the electrical vehicle in terms of the two-wheeler or four-wheeler. Then next generation and future, they are introducing the autonomous connected vehicle. Nowadays, we purchase the vehicle means we have here some more sophisticated, more future is there. Like ADAS system is there, adaptive cruise control, land keeping assistance, some more future is there. The same that continuation, there without the human, they are drive the vehicle. That is the autonomous connected vehicle. Actually, in this autonomous vehicle, not only the car with the computer. It's like about the autonomous connected vehicle means you give the information, transmitter and receiver, everything is there. Okay, so that is the autonomous connected vehicle is a cyber security system also we can take. We have in the autonomous connected vehicle means a more number of sensing, computation, and control and communication is there. So similarly, ADAS future ACC, then ACC definition for the adaptive cruise control, land keeping assistant, forward FCW is a forward collision control, automatic emergency braking. So they're already used in the modern vehicle. So that continuation only is the autonomous vehicle. Then can understand the function out through the small real-time LabVIEW model. Simulation build initially before moving to the hardware or road testing. Before we are to develop in the one actual practical system, we use by the LabVIEW platform to we have to simulate. That is the main aim. So now this is the lecture series from the theory to experiment concept. First, you have to understand about what is the concept related to the autonomous connected vehicle. Then we have to form the simple equation. Then we have to look at about the control logic. So we have to control the speed or distance, distance. So used by the control logic to we have to decide the output. Then next we develop in the LabVIEW platform. Then we achieve the result. Normally, all the concept we are used by the closed loop control system. Then we from the controller, then output sense the signal and feedback and generate the error. From the error, we have to control the system. Actually, this lecture series we have to avoid the more mathematical explanation. So just we have to understand about the what is the autonomous connected vehicle, small application we have to understand. The same we have to use by the simulation used by the LabVIEW platform. Okay, that is the main motto of this lecture series. Actually, the autonomous connected and the ADAS system. So ADAS system, we look at about the advanced driver assistance system. Now we have all the modern vehicle, it is available in the ADAS system. That is like about the ACC line, forward collision control, emergency braking, all is available in the modern system. The next level we have to use by the autonomous vehicle. Autonomous vehicle is the sense the signal, so sense the environment, sense the signal. Then the system is designed under control. We are not interfere the any human. Suppose we drive the vehicle, suppose we want to run this much speed means the system itself designed under process. It is the autonomous vehicle. Then same autonomous vehicle used by the connected vehicle also is possible. So connected vehicle one-to-one vehicle is possible. That is a vehicle to vehicle, vehicle to V2B means vehicle to vehicle, vehicle to infrastructure, vehicle to nearby, vehicle to pedestrian. So that is all possible. So connected vehicle. So that is the flow. So the ADAS is the normal, normal advanced vehicle. Then next level is a connected vehicle. The next we are the autonomous vehicle. The next we will go to the connected vehicles. This is the flow in the future for the autonomous connected vehicle. So normally before we go with autonomous vehicle, we want to understand about the automation level. So now we know about the various system, various vehicle is there, how much automation level is there. So initially we have to purchase the initial stage, there is no automation. Because everything you have to do in the manual. Then next you have to go with the assistant. Some partial assistant is there. Then next the next one is the L2 level. L0 level is no automations. L1 is some basic assistant. And it is like about the seat belt, always lock the door. So small assistant is there L1 level. Then L2 is the partial. So partial we look at about we go the adaptive cruise control, land keeping assistant, that is also is there L2. The next level L3, L4, L5 is there. Similarly, the full automation, full automation is there. That automation level from the L0 to L5. Now their vehicle we have up to L3 level. Then next future we go with L4 and L5, fully connected, and vehicle to vehicle communication also it is possible. Require more sensing. Suppose we go with the higher level means it is made for the more sensing, redundancy and validation, laboratory simulation focus on control and design logic. So small logic only is there. Suppose we want to understand about the concept of the system, then we have to proceed. That is the various level of the automation. That is the autonomous vehicle architecture. Yeah, so if you look at about the one autonomous vehicle, so there is a various different type of the block is there. Sensor, perceive, localize, plan, control, and connected. Final one is only the connected. Connected mean the connected from the one vehicle to the another vehicle. The initial stage is the sensor. Sensor normally in the autonomous vehicle or any vehicle we have user camera, radar, light independent resistor, perspective. That is all are in the basic sensor. The next one is first we have to detect any object, land signal. So that is we have to perspective. Then localization. We have to know about the which portion is there. The vehicle is there means we have to use by the map. Normally you know about the Google Maps used by the map to track the vehicle. Then only we want to know about the where the destination portion. So map and portion. Then we want to know about the plan. How to plan. So plan plus behavior. How do we have to travel from the one point to the another point means how to the shortest distance. There is a plan and the behavior. Then using the steering control. So you know about we go the traffic, move traffic means how to control the vehicle. Then next one is the final one is a connected vehicle to X connected infrastructure or vehicle to vehicle. Everything is there. Then final one is a connected plus cloud. The cloud is important. So the huge data is there. Suppose we look at about the one, it is not in the one single vehicle. Suppose in your future, n number of vehicle drive means each vehicle ought to get the more data, sense the data, how to process it. Everything is there within one system, within the one vehicle itself. It is not possible. So we have to everything data upload in the cloud, then processing and get back to the system. It is a process for the autonomous. This is the general architecture. Yeah, so pipeline of the system. Each block can be converted to the simple classroom experiment. So here is the more number of block is there. Each block can be converted to the simple classroom experiment. Then first 5 labs. Here in this lecture series, we have to discuss about the 5 labs. Focus on mainly on the speed, distance, and steering and safety decision. So normally in the experiments, how to control speed, distance, steering, safety decision. This all are we discuss in this lecture series. Now we have to look at about some sensors. I don't know about the student studying the UG levels. You know about the different type of the sensor is there. In the autonomous vehicle, we use the different type of the sensor: camera, radar, LIDAR, ultrasonic, and GPS IM. So this sensor we have to sense the different purpose. Camera we got to make it the land marking and sign objective. The radar we want to find out the range and the relative speed. As a 3D point cloud and shape. Ultrasonic we have to understand about the parking distance. We have to properly, effectively park the vehicle. GPS and IMU position and motion state. So now we are to look at about the different type of perception, the sensor data to the road understanding. We are to take about all the sensor. Sensor get the data based on the data, raw signal. We have to get the signal. Then you have to do the processing. So we have to filter the noise. We have to get the signal, get the data. So we want to extract the what all are the main data. So they filter the unwanted data. Then you have to detect. So then land object detect, track motion over time, estimate distance or speed. So land position we have to find out the land error, distance sensor we have to find out the safety decision, relative speed, so time to collision. So normally in the autonomous connected vehicle, main thing is a decision and the planning. Choose what to do the next. Suppose you want to drive the vehicle, so identify the distance, how much speed you want to drive. Okay, so that is you are based on the distance. Suppose very short distance means you have to reduce the speed. So long distance means you have to run with the normal speed. Suppose you want to sudden decision. Suppose suddenly the front car that suddenly they apply the brake means you want to suddenly have to apply the control. I want to reduce the speed. So that is a decision and the planning is the very important. Suppose you look at about you have to drive the vehicle. Suppose you change the land. Suppose another land is there is the free means. So you can able to change the land. That is the planning is the important. Decisions and the planning is the very important. So behavior planning decide high level actions. So follow the slow down, brake, keep the land or change the land. So path planning, select the divide. So we want to choose the correct path planning. So that is the important thing. Speed planning, determine how fast the vehicle should move under the constraints. So for UG experiment, we have to identify the some small cases to understand the decision and the planning. So front car close, decision, reduce the speed, command the brake or throttle, response, speed decrease. So this kind of the understanding needed. How to apply, how to use the small electronics component to how to achieve this kind of the plantation and planning. So normally here used for the full and full in the control system making vehicle act. So based on that controller, we have to take the based on the error signal, we have to do the control. Okay, suppose we are to use by the speed means the desired speed minus actual speed. We have to run the one particular speed means how to find out the speed error means we have to write the what is the desired speed, subtract with the actual speed means you can find out the speed error according to we want to control the send the signal to the control. Throttle controller we are use the KP into speed error. The proportional gain value. So there is an into speed error. We have to we give the command to the throttle. Land error, land position and land center. Steering angle also used by the controller KP proportional gain controller to the land. So actually in the control system is the main aim, main role for the autonomous connected vehicle because the decision and everything is main. Then how quickly make it the decision? Because this is in lively run the vehicle, so you want to quickly make it the decision and the processing. So now you look at about the how they're connected vehicle. So you see that the vehicles, a number of vehicles there means each vehicles to vehicle connection. Similarly, you have to this data sent to the cloud. It's not meaning for the vehicle to vehicle communication. So that is you have to send the data to the cloud. From the cloud only you have to communicate to the another vehicle. So different kind of the communication. So vehicle to vehicle communication is like about the V2V. V2I means a vehicle to infrastructure. V2N means a vehicle to network. V2P means a vehicle to the pedestrian. So that is the information needed. According to we want to run the vehicle smoothly. So in your future, first we want to develop in the connected vehicle. Then in your future concept is a connected vehicle beyond the onboard sensing. So beyond the onboard sensing, we have to use by the connected vehicle. Suppose the one vehicle travel means without sensor, we can predict the path land. So we can able to understand about how it travel. So based on the nearer by vehicle position, we can travel. This is also possible in that our advantages and future in the connected vehicle. So this is the safety is the important. So yeah, inside the vehicle driver and as well as the pedestrian. So we have to cross the pedestrian unknownly means you want to quickly identify the object and you have to stop the vehicle. That is the important. This is a safety mindset, predictable, boundary, and testable. So we are to predictable. So same input should be lead to the expected output. Boundary, the throttle, brake, steering limit must be enforced. Fail safe, unsafe situations should move towards the warning and braking. Validation, test case must go over the normal and the critical scenario. Why LabVIEW for the learning the series? I know about the LabVIEW is one of the interesting platform for the front end panel. So you want to in your higher when you go with that any high industry or anywhere industry means they're using the LabVIEW because the front panel they are want to controller and the slider control logic expression means it is a very easily we can do it by using the LabVIEW. Okay, we normally in your lab how their input you have to slider or control this much speed needed, this much distance is the maintain the safety distance means. So those given we are used by the slider or control to give the input. We do in some basic logic operation. It's not in the complicated equation, differential integration equation. Just we are doing the normal logic or math equation to identify the function. So based on the function, you have to give the display the part. So similarly, those response we want to make it the data, store the data, chart, preparing the chart, how they are respond. Okay, for one particular time period, how they are respond. That is the main thing we have to go with that lab. So this is a front panel behavior like a vehicle dashboard. So now you know about the vehicle dashboard. The same kind of vehicle dashboard we have to develop in the LabVIEW platform. So block diagram shows sensor input, control logic, and actuator output. A while loop enable the real-time exhaustion. So waveform chart gives the immediate dynamic response. Case structure makes the decision logic clear in the ADAS function. So that's where we go with the LabVIEW learning in this series. Actually, in this lecture series, we discuss about the 5 different type of the controller. There's the one by one we discuss the coming lecture. Then first one is the cruise control, maintain the desired speed, adaptive cruise control, maintain the safe distance. So there is a normal cruise control, adaptive cruise control. It is look at about the maintain the safe distance. Now it is a cruise control means that it is a normal vehicle means that we have to in the driver can able to see the distance for the other vehicle. But in autonomous vehicle means it is not able to see the vehicle. Only sensor only. See, that's why we go with the adaptive cruise control. Land keeping assistant control the land position. So forward collision warning, automatic energy braking. These all are in the 5 basic experiment you have studied in this series. So basically the learning logic, speed, steering, warning, and brake. This kind of the concept of the used in the LabVIEW experiment. Say here in this introduction series, we are to simply we discuss about all the experiment introduction. First one is the cruise control, speed regulation. Just we have to maintain the constant speed. Okay, and, nowadays in the advanced vehicle, they are used in the cruise control. It's maintain about the constant speed based on that driver. So the driver drive with the highway means they are maintain about the constant speed. So the speed, error, distance, speed, and the actual speed. So throttle command we can use by the KP and the speed end. Input normally used by the desired speed, actual speed, and KP bar. We want to maintain about the 40 or 70 or 90 kilometer speed means we have to fix the desired speed is the 90 kilometer speed. Then logic we use in the compare with the speed and throttle command. How much the 90 kilometer speed means how much throttle position needed. So that is the logic command. Output throttle command. So this is the 90 kilometer speed means how much throttle position, speed error, speed response. Check it the speed. So it is maintained about the 90 kilometer speed or not. That is the speed response. So you have to maintain about the speed response chart. Here we have to use give some student task to you have to tune the KP bar. That is the important. You have to tune the KP value to we have to exact response is the achieve. It's the first experiment for the cruise control for the speed regulation. Then adaptive cruise control. You only it is not regulate the speed. Also, you want to maintain about the distance. If distance is the greater than safe distance means it is a maintained speed. Distance is the less than or equal means you have to reduce the speed or apply the brake. So that is the second experiment, adaptive cruise control. Similarly, land keeping assistance. You want to maintain about the same like within the land you want to drive. Suppose the land portion is the changes. Anything the throttle, the changes portion means we have to maintain about the proper portion. So the land error is equal to land portion minus 0.5. Steering angle that keeping this is the land error. So that is maintain about the 30 degrees. So that the steering is the maintain about the plus or minus 30 degree. Yeah. So this one we explain in the detail in that coming lecture series. Similarly, for forward collision warning, a predictive risk, so anything that based on the distance. So based on the distance, we have to identify the how much distance in the from the front vehicle. So based on we can to identify and apply the brake. So the time to collision, use the threshold to classify the safety status. So the stated using LED and the string indicator. This is also possible. Also learn in the forward collision warning. Then final experiment is the emergency braking. Suppose there is suddenly that any pedestrian, any object is a crossing means you have to identify and apply the braking quick manner. So that is the main things. The fifth experiment. Actually, in the five different experiments we studied in this lecture series. Then cruise control, then adaptive cruise control, then land keeping assistant, and the forward collision warning, and the automatic emergency brake. Okay, this is the flow we got to follow in the lecture series. Then basically we understand what is the motivation theory, a LabVIEW panel, and developing the block diagram with the logic and writing. So run test result. So this is the flow we got to flow in that lecture series. So in each lecture series, I explain about that how to develop in the LabVIEW platform and how to use for the logic and the situation indicator, everything we can do it. You can do in your hands-on training also is possible. You can try it yourself, install your LabVIEW platform and try it for all the 5 So this is a basic assessment. So suppose if you have clear means the series means you can share your screenshot and what your observation. Suppose you have any doubt means we can able to do the assessment. Yeah, should be able to do it means the introduction should be prepared this complete LabVIEW experiment series one. We are not go with the full theory concept. So we go with the LabVIEW series one, identify the sensor, control, activator, and the communication layer. So this is all we are from the LabVIEW platform. We have to identify those things. Build a simple LabVIEW model for speed, distance, steering, and braking. Use feedback concept and to reduce the error towards the target value. So interrupt the chart can be dashboard, the output, the vehicle level language. So this next module we discuss about the cruise control using the lab. So thank you.